intense 3 minutes for you. And my name is Wojciech, and I'm representing team B17. So let me start with a statement, which is a ship is a dangerous place. You can trip and fall. You can get hit by the rod, or you can injure your knees and back. And all of it because of procedure called lashing. What's lashing? It's securing containers on the deck with the rods. But all you need to know about is that equipment is heavy. Each piece weighs around 12 kilograms or more, and it is being lifted manually. So we asked ourselves a question: how can we help Maersk and the lashers? And the answer was evolution without revolution. We know that Maersk is about tradition, so we want to change as little as possible, but still make an impact. And we tried to redesign the upper part of the lashing system and leave the lower part as it is. We can leave it for later. So we asked ourselves a second question: can it be done? So we took materials and we started comparing them. We have steel and composites, and when we compare the strength, we are 2 times stronger with composites. When we compare the density, we are 3.5 times less dense, which means that in theory, we could get the material which is 7 times lighter. So we start prototyping, and this is what we arrived at. Let me introduce you to EVO 3.5. It is a 2.5 meters long lashing composite rod, able to withstand 50 tons of load. And it consists of 2 kilograms of composite and 1.5 kilogram of steel. So, you know, it is feasible. What about viability? Well, we are competing with a steel rod which is worth 25 plus. That's not much. But estimating on the current market prices, we can estimate that the EVO 3.5 will cost around 3 times more. But trust me, it is worth it. First of all, we'll have less injuries. The work will be easier, the lashing faster, the safety improved, and there will be less mass to carry around. And of course, let's address an elephant in the room: sustainability. Well, I can say for sure that we have 4 times lower mass, which means we need to recycle 4 times less. 43% of that is steel, so we can recycle it fully. It doesn't corrode, which means we can use it for 50 years instead of 20. And we are left with 2 kilograms of composite, which we can use creatively, like this playground in the Netherlands. And of course, responsibility. In our minds, we are the most responsible to the people who need it the most, the workers. What's next? There are over 1 million rods in that Maersk vessel, and a blue ocean of possibilities ahead. We are ready. The question is, Maersk, are you ready?
All right, let's take questions from the audience. Maersk, start.
With all the wonderful ideas that were presented to us today, have you considered, since you only addressed the top part of the lesson, to work with some of your fellow students on the lower part?
Yes, we have been considering it. To be honest, we even made a sketch which is not visible, but yeah. Go back to this presentation and unhide this slide, please. Yeah. So at the beginning, we were thinking about the hull system as a one idea. So at the top, you can see the composite lashing bar, and in the top, we are thinking about some kind of automatic tensioning system. But because of the lack of time, we decided to focus on the upper part. But our research tells us that we can do also the lower part, because there are like plastics that can withstand the same load as the steel. So yeah, that's the next step.
Great, thanks.
Thank you.
Still few more minutes, so please fire away from the challenge partners.
Yes?
They usually say that if you make a new product, you need to make it probably at least 10 times cheaper, because there's the whole cost of switching to a new solution. And in this case, it's still more expensive. And next to the healthcare benefits, is there any other ways where you could see that you could lower the cost or do something else to make Maersk consider using this?
So first and foremost, we wanted to be true about the cost. So what you see is, let's say, a bit overestimated. So I guess we can always go lower from 75. We prefer to say it's more expensive and go low than say it is cheap and then give a price which is 10 times higher. When it comes to cost, the first thing is that we don't want cheaper, we want better. And health is priceless. Yes.
Very nice presentation. I really enjoyed it. What about the aging or the fatigueness in these composite materials compared to the conventional materials?
Yes.
Have you studied that?
Yes. So we have interviewed the specialist in wind turbine composites, and the feedback we got was that the composite materials are better in terms of fatigue. There are also some, there are of course some drawbacks, like composites being prone to UV light, but that's just the coating that we need to do. And if a wind turbine can stand there for 50 years and generate the power, why can't we use this?
Let's take some questions from the audience. Stu? Or if any of the challenge partners have a question. We still got 2 minutes.
Yes, please.
So thank you. I thought that I really enjoyed your presentation. Very professional. So I'm considering if you would produce these materials, I mean, you need composite and steel put together. Can you see any difficulties in combining those two materials?
I mean, for sure, the R&D will take a while, but this is the knowledge that we have. We are using it. When you see the example with the turbines, they are also a combination of steel and composites. So there's a lot of research investigating the different cohesion and adhesion problems, but it is possible. It is more possible that we can imagine. And also the design itself is made so we don't fatigue between the metal and the composite, because as you can see, the S-class composite, the fibers go all around the metal parts. So the metal parts are pushing as a finger on a rubber band. So it is just being stretched, and the design allows us to withstand the load. But thank you for the question.
All right. Thank you so much.